Hello, testing, testing, one, two, three. Testing. I think my mic has been muted. Hello, testing, testing,
There we
one, two,
go.
three.
Cool. All right. Hello and welcome back to another episode of Conquering Physics, where we just try to work out some physics problems from the Conquering the Physics GRE book by Yoni Kahn and Adam Anderson. And today's problem is still in the topic of moment of mass, or center of mass problems. And the problem today specifies a block explodes into three equal pieces. Piece A has speed v after the explosion, and piece B and C have speed 2v. What is the angle between the directions of piece A and B? Okay, what's interesting about this problem is it really doesn't specify much. And so I think we have to make a couple assumptions. So we have a block, right? And then boom, it blows up into three pieces. Piece A, piece B, and piece C. Oh, it says equal mass, so each of these have mass m. Let's pretend that they're the same size. Okay. And so we're going to make an assumption also that they're probably blasting off outward. And so the question is, what is the angle? Oh, so for A, blast off with speed v, and these two are 2v. And so that's going to kind of give us a hint in terms of like what direction and everything that it's going in. So our initial guess. So if let's just take it back. We start off with a block. We're going to assume it's in rest, right? So it has no velocity. So momentum total in all directions, x, y, and z, is 0 in the x direction and in the y direction. And so what's important for this problem is that there's a conservation of momentum. So the momentum before or initially has to equal the momentum after. And so we know that in that case, then the momentum in the x direction has to equal 0, and in the y direction, the sum of the momentum in the y direction has to equal 0. So there's a lot of different things we could do with this problem. So the question says, what is the angle between A, and B? And so let's rotate this real quick. I don't just kind of imagine them being little blobs. And so if this thing's moving out V, then we know that these two kind of have to move out in a similar fashion in terms of 2V, right? Because they have the same velocity. So let's make an assumption that there's some type of symmetry about this line. And so if you could imagine that if we were to say there's a y direction, there's a y direction up here, and there's an x direction here, we can see that these kind of balance each other out. So let's imagine they're more a little more symmetric. And so the push from in this direction is equal to the opposite push from this direction. So you see that in the y direction, momentum kind of cancels out. This one doesn't have momentum going left or right. So actually the x direction momentum cancels out. So we kind of know already that the px cancels out, right? And we can calculate that by trying to find out the angle. And so if we were to say there's an angle between these, we could make an approximation that there's an angle between here and here. We'll call this theta for now. The question really asks, what's the angle between all of this? But if we find the angle of this one is basically this one plus what this one will be. And since we divide our coordinates like this, we know this is 90 degrees. So we can just add 90 degrees to whatever angle this is. And so off to the calculations. So we know our x direction is going to be 0. But let's play around with the y. So with the y, remember, momentum is equal to the mass. So the mass of this one's m, as is for all of these. M times v, and it's entirely in the y direction, so that's all we have to worry about. And so notice that these components, they're kind of going downward, right? So there's a y component going this way, and there's a y component going this way. Or x component going negative, and a y component going negative for this first one. And so this is going to be equal to minus m v, and since there's a theta here, remember our rule of um, opposite over hypotenuse, so it's going to be a sine theta. Oh, my apologies, right here, this should actually be 2v. And we get another, when we calculate this, we see that this is as well going to be the same theta because of symmetry. So we have m2v sine theta. And remember, this is equal to 0. And so when we go off to solve this, we can basically isolate for this sine theta. And so we have mv, we can factor all that out from everything. We get 1 minus, and then for when you combine these two, you get minus 4 mv sine theta. And so when you factor out the mv, you just left with 1 minus 4 sine theta is equal to 0. You could divide both sides by mv, and you're left with 1 minus 4 sine theta is equal to 0. And then you get 1 minus 1 is equal to, because you can add 4 sine theta to both sides. You get 1/4 is equal to sine theta. Or sine theta is equal to 1/4. And so when you solve for this, it would be arc sine theta of 1/4 is equal to arc sine of 1/4 is equal to theta. And so the interesting part is, if you look at the answers, the first one is pi minus arc cosine 1/2. Pi minus arc cosine 1/3. The same but 1/4 for D. And then for E is 0. And so just from calculating this stuff, as we mentioned, we know it's going to be this angle plus 90 degrees. But another way of looking at it as well is you can look at it as pi, so this whole thing minus this angle. And so if you were to solve for this angle, it's going to look a little different. And so let's try to see if we can figure that out. In this case, what we ended up finding is that it's pi over 2 plus arc sine 1/4. But that's not an answer that we have available to us here, at least immediately. But if I was to guess, I would probably guess D due to some type of symmetry, and we have, oops, this should be 1/4. We have 1/4 inside of it, and they have 1/4 inside of it. But let's try to be a little more rigorous. Okay, and so here, if we were solving for this angle, and we're looking at the y in this direction, now since we're looking at it like this is hypotenuse to, and then this, or you could think of this, it's going to be adjacent, so then it would be cosine. Yeah, and so in this case, it would be pi minus arc cosine 1/4. So it's the same thing. We get D for this. Yeah, and for this one, I'm probably gonna leave it for that. I hope that kind of made sense. If you have any questions with regards to that, I could try to explain it clear. I'm actually gonna end this episode, and I'm gonna go into a different discussion. So I'll end the stream and start up another one for another interesting topic. Okay, but thank you for joining, and hope that was helpful in some way. Bye bye.